welcome to your weekly introduction videos. This week we're going to be looking at area and perimeter, mainly of a shape called a sector. And I hope that you know what that is already, but if you don't, we'll learn. What I do need you to know though is how to find the areas, possibly perimeters, of some very basic shapes. So we've got three questions here. Question 1, question 2, question 3. You should already be able to do these questions. So just stop the video and have a go at them, and then we'll go through them. Okay, so hopefully you've done that. Obviously the basic strategy is to split them into two. Look at the first one. Split it into two shapes, a rectangle and a triangle. Okay, the rectangle, it shows, so area of 1, the rectangle is very easy. That has formula of base times height, which is 48. And the area of shape 2, which is a triangle, has base times height and divide by 2 because it's a triangle, which would be, 30, that would be 15. And so the total area is going to be equal to 48 plus 15, which is going to be equal to 63 centimetres squared. Okay. Second one. Again, we're going to split it into two shapes. We're going to try and find the area of this logo. Now, shape 1 is a trapezium. Now, have to try and remember the formula for the area of a trapezium, which will not be given to you in an exam. Okay, so it's this. It's A plus B times the height divided by 2. A and B are the pair of parallel sides in the trapezium. What makes a trapezium is that it has one pair of parallel sides. So we add together the two parallel sides, which is this length and this length. After doing that, we then times that by the perpendicular height of the trapezium, which is 6, and then we divide by 2. So that becomes 18 times 6 over 2, which is 54 centimetres squared. Okay. Then what we need to do is find out the area of the triangle, which again, base times height divided by 2. So the base is 12. Height is going to be this distance here, which is 15 minus 6, so that's 9. Okay, which is, so 12 times, I don't know, to be 6 times 9 is 54 centimetres squared as well. So actually the area of the triangle and the area of the trapezium are the same. So the total area is equal to 108 centimetres squared. So you should already be able to find the area of a rectangle, area of a triangle, area of a trapezium. I would also actually, just while we're at that, expect you to be able to find the area of a parallelogram. So just remind ourselves, a parallelogram has this equation. So if this is 4 centimetres, this is 8 centimetres, and the perpendicular height is 5 centimetres, well, an area of parallelogram is base times height. Perpendicular height, not slanty height. So that'll be 40 centimetres squared. Okay, so basic stuff I expect you to already know. Okay, question 3. I also expect you to be able to know about areas of circles and semicircles and quarter circles and that kind of thing. So if you remember, the area of a circle is equal to pi r squared. So the area of a semicircle must be pi r squared over 2. Well, what is the radius for this particular circle? Is 5. Okay, it's not 10, the diameter is 10, the radius is 5. So it's going to be pi times 5 squared divided by 2. And so the area, now just using my calculator, I'm going to write it to 3 significant figures. So shift pi times 5 squared divided by 2 equals, according to my calculator, 39.3 centimeters squared to 3 significant figures. Not exactly, but to 3 significant figures. So now we need to say that what's the side length of this square? Well, since they have the same area, it must mean that x squared is equal to 39.3 to 3 significant figures. So x is the square root of 39.3. So let's just root my answer on the calculator. To 3 significant figures, I'm going to get 6.27 centimeters. 3 significant figures. Okay, there's my answer. So I expect you to know that the area of a circle is pi r squared, and so the area of a semicircle is pi r squared over 2. I also expect you to remember that the circumference of a circle, so that if we've got a whole circle, that distance all the way around has a formula 2 pi r, or pi d, pi times diameter. Okay, you should already know that. If you don't, you've forgotten, practice it, remember it. There is 2 My iMaths assignments to help you practice these concepts. One on finding the area of a trapezium, one on finding the areas of circles. If you feel like you need to practice anything else, please let me know. I'm happy to provide you with that on an individual basis. Okay? Right, okay. So, with that in mind, what we now need to be able to do is find the area and perimeter of a sector. Okay? Now on the left-hand side, we've got things that are sectors, and on the right-hand side, we've got things that are not sectors. Okay? Now the best way of describing a sector is it's like the same shape as a pizza slice. Okay? So it's made up of 2 radii and an arc of a circle. Okay, that is a sector. So, for example, this is not a sector because it's not made up of 2 radii. Okay, this one is made up of a chord and arc of a circle. That does have a name though, and it's very important that you know it. This is called a segment, because we will be looking at how to find the area and perimeter of a segment. Okay? Now this one here, this is clearly not a sector, because these 2 lines again are not the radii, so it's not a sector. Okay, they have to go from the circumference to the center, otherwise it wouldn't be a sector. I don't really know what the name of this shape is. I'm not sure if it has one or not. It'd be very rare that you have to work with a question like that. Okay, so we're wanting to know the area and perimeter of a sector. Now, so just be absolutely clear what we've got. This is what we call a minor sector, and this is what we call a major sector. Okay, this area here is the major sector, and the red one is the minor sector. Same with this, we've got the minor arc and the major arc. So just in case we don't know which arc we're talking about, or which sector we're talking about, is it the bigger one, is it the smaller one? That's how we call them. Okay. Now, how do we actually find out what the, let's say we're trying to find out what the minor sector area is. Okay? Right, now, this is how we do it. The best way to do it is to understand that the sector is simply a fraction of the entire circle. And what fraction of the entire circle is it? Well, what we do know is that the angle made up between the 2 radii is 103 degrees out of what would normally be entire way round would be 360 degrees. Okay, so we can say that this sector is actually 103 360ths of a full circle. So all we're going to do is times that by 2 pi r, and that will give us that area. Okay, and it will be the same for an arc length. The arc length will be 103 360ths of the entire circumference. Okay, so there is the formula. We can speak more generally now about what the formula is. The arc length, the sector area is the angle of the sector divided by 360. Oh, what a fool. Didn't even notice my own mistake. That should be pi r squared. Hopefully you were yelling at the screen to spot that, because this is area. So it's theta over 360. Theta is, remember, how we denote a missing angle, times pi r squared. So sector area equals the angle over 360 times pi r squared. It's just a fraction of the area of an entire circle. Same with the arc length. Arc length is the fraction of it as an entire circle times what the circumference would be if it was an entire circle. Okay? So it's that easy. They are the formulas. You need to write them down. Again, you will not be given these formulas in any booklet or anything like that. You just have to remember them. I think they're pretty easy to remember, these ones. Okay. Right, so let's just check we understand some things. The shaded part of the circle is, what is it? Is it a sector, a segment, or neither? This is definitely a sector. What about this one? Sector, segment, or neither? This is neither. Absolutely nothing. Okay, I don't know what you would call that. And what's this one? Well, clearly that's the remaining one. This is a segment, the area between a chord and the arc of a circle. Okay, what fraction of the circle is represented by the shaded colour? It's the angle of that sector as a proportion of the entire way around the circle. So 137 over 360. So basically the shaded area, we can sort of see that as 137 360ths of an entire circle. Okay. What fraction of the circle is represented by the unshaded sector? Well, obviously that's going to be that one, isn't it? Okay, the major sector is 223 360ths of an entire circle. Okay, so all we've got to do here is find the area of each sector, okay, using that formula. So the area is equal to the angle of the sector divided by 360 times pi r squared. R is the radius of what would be the entire circle. Okay, so stop your video and see if you can have a go at these, writing your answer to 3 significant figures and in terms of pi. So you can write an accurate answer or a rounded off answer to 3 significant figures. Stop your video and have a go. Okay, here are the answers. Okay, so 3.14 centimeters squared, that's the same as pi. 12.6 centimeters squared to 3 significant figures, that's the same as 4 pi, so on and so forth. I hope that would be very easy, or just literally following the formula. Okay. What about these ones? Same. Have a go. Stop your video and have a go. Okay. Here's the answers. Okay, so remember you can leave things as fractions if you need to give an accurate answer. Say this is paper 2 and you don't get given a calculator, then you can leave your answer in terms of pi, and you can use fractions. Okay, this time you have to find the arc length of each sector. So we're trying to find out what this distance here is. Okay, stop your video and have a go. Okay, there's the answers. Please let me know if there's any problems. If you don't understand something, just ask. Okay, what about these ones? Stop the video and have a go. There's the answers. Okay. And finally, can you find the perimeter of each of these sectors and write your answer in terms of pi? So be really, really careful. We want the perimeter. So we're going to find the perimeter. We need to find first the arc length and then add on the 2 radii. Okay, because perimeter means the distance around the entire shape. So that's an arc length plus 2 radii. Stop your video and have a go. Okay, they are the answers given in terms of pi. Of course, if the question asks you to give them to 3 significant figures, you just pop that into a calculator and work it out, round it off appropriately. Okay, right, I'm going to stop the video there, and part 2 is on its way, where we're going to learn how to calculate the area of a